Okay.
Special guest Federico.
Yeah, and I want to start off by saying, Nick, you've just been doing such a great job running the
There's my
the
sarcasm's clap.
I hear there's no sarcasm whatsoever. And it took me a while to find this. I was saying that this is in the Mentors Extra channel that I think we need to recognize. Matt, Mike, Nick, Joseph, and Nicolas are stepping up in their roles and running the mob seamlessly. And we need to give them not the Tech for Good awards, but we need to give them the Federico Esparza Standard of Excellence AV Mentor Award. Even though it doesn't exist, Joseph found that. But yeah, I just want to say that I really appreciate it. You've been able to do that for us. Hopefully it's been okay.
Yeah, well, at the beginning of the session we had 0 participants, and now we have like 2, I guess, if we count you, Federico.
Yeah.
So far so good.
So we were gonna learn some Haskell.
Haskell.
Yeah,
Haskell.
Thanks
How do you pronounce?
Yeah, I thought it was Haskell.
Oh, look, how to pronounce Haskell. Sounds like a robotic voice.
Oh, actually, we couldn't hear that. I didn't hear that, at least.
Yeah, sorry. Let me unplug my headset.
I could.
Haskell.
God, that's
Can
all.
you hear that now?
Yeah, but can we get a better version?
What?
Can we get something else?
Haskell.
Yeah.
Haskell.
That's it. I'm not pressing play on any other ones.
Okay.
You're right, Federico. You're right.
But I kind of like Haskell. I'm gonna start saying Haskell just to throw people off. So what do you think of it, by the way?
Me? I like it.
Really?
You can do some pretty cool stuff with it that you can't really do so easily in other languages.
Mm-hmm.
But there's definitely trade-offs, whether if you're going to use Haskell or some other language. There's always trade-offs, right? So,
yeah.
So far it's pretty good because in the book that we're going through, there's lots of like different ways to do recursion.
Mm-hmm.
So it starts off with like the general, the way everyone learns how to do recursion with like the Fibonacci sequence, and it's a very inefficient way, and then it shows you how to do it more efficiently so that you can calculate Fibonacci of like 10,000 pretty instantly.
Okay. What I'm kind of curious about is, other than sort of algorithms type of like problems, are there any like frameworks, or is there any real?
Yeah, there are.
Used to Haskell, like for.
I mean, they do everything in Haskell. They got web frameworks and all that.
Yeah. Okay.
What they're called, I don't know. I thought there was something. Let's see.
Yeah, I mean, because I don't know if I really want to invest time in learning it, if I can't really use it other than?
Well, why don't you create your own framework?
I don't know about that. I mean, it would increase my presence, right? As an authoritative, as an expert, authoritative expert or something.
So Haskell is good. So Haskell is right here. It says it's a purely functional programming language,
Hmm.
and like it is. Yeah, it's if you want to write functional programming or if you want to learn functional programming, then Haskell is the way to go.
You know that.
And then you can apply that to any language, because a lot of languages like JavaScript, Python, Ruby, they're all got some form of they're a multi-paradigm language. Like Ruby's more object oriented, but it still has some functional programming in it.
Right.
Same with Python. Python, you can do object and functional programming. Same with JavaScript, you can do object oriented and functional programming.
And that's exactly why. So I mentioned before during the pre-show that the guy from the Elixir Outlaws, the co-host, his name is Amos King. That's the reason why he wants to learn Haskell. It's so he could better understand functional programming in it, because he uses it in Elixir all day. And
yeah, there you go. Snap. There's a good reason to say snap, Federico. So framework for the Haskell programming language.
Oh, really? Wow.
So there's another one, Yesod.
Yeah, I don't know. I'm a little suspicious. What's up with that name?
Yeah, I would go with Snap just based on the name.
Yeah. Wait,
Who cares if Yesad's been around longer and is.
Have you ever heard that word, Mikhail? Is it French? Yesod. Yesod.
Mm-hmm.
Have you heard of that word?
No. No.
Yeah, I don't know.
Hapstack.
There's Hapstack. Look at all these. Spock. You have Spock web framework.
That's okay. That's better than Yesod or Yesod.
Web.
Yeah.
All right. Yeah.
You gotta think about that a little bit, because, like, you know, like for your resume or things like that, or just like conversing with people, you're like, oh, yeah, I work mainly in Yesod. Or
Spock. I'm a Spockster.
I'm a Spock engineer.
Spock engineer. Yeah. So I mean, yeah. So I mean, Haskell, it's a functional programming language. It is declarative, more or less statically typed. Yeah, there's lots of people use it. Yeah, it's out there.
I know, but I thought it was like a lot more sort of esoteric and academic.
No. I mean, I think maybe I wouldn't say it's esoteric. I mean, people do use it. People do use it in the production code.
Okay.
So.
Well, could you catch us up on what you're working through a book, I think?
Yeah, so I was working through a book, but there's also, I thought, you know, if you go to this website here, and if you want to try it without installing anything on your computer, or they got a little interpreter here. You can type Haskell impression. You can try it out right here too. Now let me share my. So yeah, see, they got a little Haskell interpreter built into the homepage there. And then I believe also they got a tutorial.
That's very impressive. A little REPL right there, interpreter right there.
Yeah, I thought there was a tutorial on here too that gets you started real quick. Got 5 minutes. Oh, type help to start the tutorial. So if we type help, there you go. So there's a tutorial right there on the main
Wow,
page.
that's cool.
So it shows you can do basic arithmetic, or you can do arithmetic in Haskell, 5 plus 7. Let's try something different. Type your name. So here it says, when you type a name, it's saying, okay, this is the returned value, and it's telling you the type. And a string is just basically a list of characters. And yeah, so you could go through this tutorial to get a quick feel for it. Or I could do all the typing.
I mean, yeah. Were you offering that we do that right now?
Nah, you don't need to do it right now.
Okay.
But it's there if you want to go through it. Let's check out this book, I guess.
Sure.
So,
oh, this is that 7 languages book.
yeah, so this is 7 languages in 7 weeks. So basically, you could probably go through this chapter in 1 week. But we've been going through it about an hour each week, so we're not really that far.
Well, I mean, mobs usually slow everything down.
Yeah, so it's taking a lot longer than I had hoped. So I was thinking maybe last week we just wrap up this book in the next week or two. Just go to day 1, finish off day 1, and they got some interesting questions at the end of day 1 that we could try to solve.
Okay.
So it kind of gives you an introduction here. Haskell represents purity and freedom for many functional programming purists, blah, blah, blah. And he says he thinks Spock from Star Trek represents Haskell. He does that with each programming language. Because Spock's character has a single-minded purity that has endeared him to generations.
I don't know what that means.
Yeah, I don't know. Anyway.
There's Erlang there, which is where Elixir comes from, builds on top of.
Mm-hmm. So here gives you a little history, I think. So yeah, I should start with the history. In the early mid-'80s, pure functional programming splintered across several languages. The key concepts driving new research were lazy processing, as we encountered in Clojure, and pure functional programming. So yeah, Haskell, embraces lazy processing, and you can do some really cool stuff with Haskell because of that. A group from the Functional Programming Language and Computer Architecture Conference in '87 formed and decided to build an open standard for a pure functional language. Out of that group, Haskell was born in 1990 and revised again in '98. The current standard, called Haskell 98, has been revised several times, blah, blah, blah. And the new version of Haskell called Haskell Prime. So Haskell was built from the ground up to be a pure functional language, combining ideas from the best functional languages with special emphasis on lazy processing. So it says it's a strong, static typed like Scala. The type model is mostly inferred. and is widely considered to be one of the most effective type systems of any functional language.
That is nice because,
Yeah, it's really, really nice that it's inferred.
yeah, because I mean, you get the benefits of statically typed without such of the hassle,
But, yep.
so much of the hassle.
Yeah. So yeah, you get it allows Erlang style pattern matching and guards. You'll also find closure style lazy evaluation and list comprehensions.
Wow. Okay.
And then as a pure functional language, it has no side effects. Instead, a function can return a side effect, which is later executed.
Okay.
Then you'll see an example of this in day 3. Something called monad. So let's see, the first couple of days will get you through typical functional programming concepts such as expressions, defining functions, and blah, 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 blah. Then, yeah. So anyway, so that's a little bit of the history. Then it goes into day 1, like in order to, like he does this thing with all the languages in this book. Like he says, if you want to learn a language, the best thing to do is just, you know, that's what I want. So it's just to start playing around with the language and see what you can do. So here, if I want to start up, so this is a Glasgow Haskell compiler interpreter. So it's basically opens up a REPL.
Okay.
So Haskell's a compiled language, but they do have a interpreter you can use to. So basically, you know, you put in 4, you get back 4. You can do, it shows that you can do arithmetic. If you want floating point number, all you got to do is add it to another floating point number. And then here it shows that the order of operations works just about like you'd expect, right? 4 plus, so 5 times 2 is 10, 10 plus 4 is 14. So yeah, so you can do order of operations. And then you can do parentheses in your arithmetic. So then he starts testing out strings, right? You put in hello, you get back hello. We try to do string concatenation, hello plus world, you get an error. This error is saying that we passed in a number. All right. So it's saying we're using the plus operator, but we passed in a string of characters instead of a number. So the plus operator only works with numbers. It doesn't work with a list of characters. So it only works with numbers. So in order to do string concatenation, you use 2 pluses. So hello plus plus world. And then you get back hello world.
Yeah.
And then for then single characters are represented with just that single quote. And then if you do a list of single characters, pretty cool, you get back a string, AB. It's basically, a string is basically just a list of characters and vice versa.
By the way, they do it. The data structure is mainly lists. There's no array.
Sorry, I call lists arrays and arrays lists. They kind of mean the same thing to me.
Oh, and the reason I mentioned that is because, for example, in Elixir, in Erlang, there's lists. There's no arrays.
Right. Okay.
And so I wondered if it was the same.
Yeah. I mean, I don't really know. I think some languages, all I know is that they mean the same to me. Because it seems like some language like Python will call them list. Other languages like Java or like, yeah, other languages will call them arrays. But I don't know if there's like really a difference between a list and an array. Kind of like, is there really a difference between a function and a method? There probably is. I mean, there kind of is like some slight difference, right?
Well, I'd say that there is.
Yeah.
Cases.
So method is more or less for object-oriented programming, I think, right? And then when you get a function, that song is, it's usually not inside of an object. That's kind of outside of an object.
Yeah, and then for lists, list and arrays. So lists, depending on the implementation, but they could be like a linked list where you traverse through the nodes to sort of read an element from the list, where an array, it's indexed, and so you can, based on where it is in memory, like if it's the third element, you can read it in constant time. So
yeah, I guess that depends on the implementation. But
yeah,
in Python, they have lists and you can index them in constant time.
yeah. So
And in Python, they call everything functions. They don't have methods.
right, yeah.
So
and it's mainly and it's kind of like Ruby, where it's mainly everything's an object.
yeah.
So yeah, I mean, I'm with you. It's generally exchangeable.
Yeah.
But I was just curious because of the in Elixir it's explicitly lists.
Okay.
And there's no arrays. So I was just comparing it to Elixir. But sorry to take you on that tangent. Continue if you want. Okay.
Oh, here we go. So
go ahead.
The author says, notice that a string is just a list of characters.
Okay, all right.
Right there.
I was gonna say I shouldn't apologize because you're Mr. Tangent when
really? Oh yeah.
When I'm trying to run the daily code kickoffs.
Yeah. Is that why you stopped? You couldn't take any more of my tangents?
No. I actually love it. I don't mind it at all. It's great. I can usually get back to what I'm driving at or my point, whatever. So,
all right,
so not to throw you off, but you were talking about that list, how it's really like a string.
Yeah, and in all programming languages, a string is basically a list of characters, but here you really see it in Haskell. You really see that it is just a list of characters. You don't really see it in other languages as it's kind of hidden from you. But let's see, let's go on. So Booleans is another primitive type. It works pretty much the same as in other languages. So here you got 4 plus 5, 9 is equal to 9, which is true. And then to do not equal, you do the / and equal sign. So is false, not equal to true, and you get back true. False not equal to false. False, right? So this is not equals, and equals is done how it is done in most other languages, the double equal sign. And then here it says try an if then statement. All right, so let's do that. Let's do if 5 is equal to 5, which is true. Then let's return the string true. It throws an error. There's a parse error. So parse error, possibly incorrect indentation. So it's saying that's the first major departure from other languages in the book. Haskell, so indentation is significant in Haskell. So it's guessing that there's a follow-up line that's not indented correctly. And the reason why it's thinking that is because if right here, if is a function. It's not like a control statement. So like in Ruby, you could put if this or else that. You're basically controlling the flow of the code. But here, if is a function. And much like Ruby, where everything is an object, well, in Haskell, you can think that everything is a function.
Okay.
So you can write functions that return functions. Every function returns something, right? So an if wants to return something.
Okay.
It's a function. It takes two. So let's see, what does it say here? Let's do, so yeah, so you have to do the full if then else statement. So the if function is expecting then and it's expecting else. You have to have it.
Wow. I don't
So
know.
here we go. Else false. And here it returns true.
Yeah.
So yeah,
That's pretty horrible.
you can do some pretty neat stuff with it though.
Really? Okay.
Yeah. People who are smarter than me can do some pretty neat stuff with it.
Haskell.
So it says right here in Haskell, if is a function, not a control structure. Basically means it returns a value just like any other function. Yeah, basically means it returns a value.
Okay.
So here we'll try if one, then true, else false, but you get an error because we passed in a number, but it's expecting a type Boolean. So unlike C, 1 doesn't equate to true. 1 is just 1.
Yeah.
So it's saying you have to use a Boolean type. Yeah, if takes strictly Boolean types. Let's try to force another type collision. It tries to do a string 1 plus 1, and again, we already saw this earlier, the plus operator wants a number. It doesn't want a number and a string of characters.
Mm-hmm.
So yeah, it's saying there is no function called plus that takes a number argument followed by a list of characters. And it says, notice that we haven't told Haskell what types things are. The language is inferring types based on clues. At any point, you can see what Haskell type inference is doing. And here it says :t. If we set :t, it says plus t. That turns on like the type system. So here it's saying it's not working exactly the way it's supposed to, it seems like on my system. But here you type 5 and it's saying it's an integer.
Okay.
And then 5.0, it's a double. Hello's list of characters.
Boolean.
Yeah, and then Boolean. And then here, this is kind of the type system here. It takes in a number P and it returns P. So it's saying, okay, well, we're going to take in a number and it returns that number. That's what It's basically, I think, yeah. So if we do like 5 plus 5, yeah, the again, it takes in a number A and returns number, the same type. So let's see. So yeah, so let's get into a function real quick.
So they actually have classes?
Let's see, what is this? The console will try to treat numbers as generically as possible unless you have done a set T. Rather than a pure type, you get a class, which is a description of a bunch of similar types. We'll learn more in classes. I don't know. I don't think we've gotten to this part in the book, and it's been a while since I've read this. So
yeah, it's definitely not the same type of class as like object oriented.
yeah, I would say that's incorrect.
It's like a grouping, I guess, grouping of types. And it's not, I don't think it's really like modules either, though.
The concept is called the class, but be careful, it's not an object-oriented class because there is no data involved. In Haskell, classes let us carefully control polymorphism and overloading. For example, you cannot add 2 Booleans together, but you can add 2 numbers together. Haskell allows classes for this purpose. Specifically, a class defines which operations can work on which inputs.
Protocol, and so I don't know if a closure protocol is like a Swift protocol, but like a Swift protocol is like an interface in Java.
Okay, yeah.
So I think it's sort of saying like almost like a species type of thing, like I don't know, maybe that's bad. A bad analogy, but the types of groups that can sort of be overloaded together, I guess, in operations.
Okay.
I guess is what it's sort of saying. Okay. Classes do support inheritance. What? What? So I don't get that.
Yeah, so it's saying, so in Haskell, classes let us carefully control polymorphism and overloading. Classes do support inheritance.
Okay, so it's almost like maybe like structs, but it's like, yeah, there's in structs you can have data, I guess, but anyway, it's sort of like classes without any of the data or methods.
That's what it seems like.
Yeah.
So that you can do inheritance,
Right.
polymorphism, overloading.
Yeah. Okay, that sort of makes sense. Yeah.
It's interesting. I think it took like 7 people to I think 7, like about a group of people, right, created this language. So
I don't know. I think it was a bunch of professors. No,
it might have been.
maybe I'm confusing it with another functional language.
All right, so in the console here, we can create a function by using let. So let just controls the scope. So yeah, if we do let x and assign it to 10, although they don't say assign it, they say binds. You bind a variable to a function. So we're binding this variable to this value 10. So now x is 10, right? And we can use it. We could say now let double that takes in. So double will be the name of our function. Let's see if this is big enough. So yeah, so let double is the name of our function, and the parameter that we pass into double, we can just call it x, and then we'll bind it to the function x plus x. So we'll basically double it. So here, so now if we say, okay, so double 5, we'll get back 10. Double 10, get back 20. And we assigned x to 10 earlier, if we say double x, we get back 20. It's pretty easy peasy, right?
I'm sorry?
What's that?
I was just going to say, so that first x is a parameter. I think you said that, but
yeah.
I was just double checking, yeah.
Yeah, so yeah, as first x, you could think of it like a parameter. So double takes in one parameter. If we just call double, it's going to say there's no instance. It takes in an integer, and it returns an integer. I think that's what that's saying. But
yeah, that's interesting language there.
There you go. Maybe you haven't applied a function to enough arguments.
Yeah, exactly. That's what I was going to refer to. You haven't applied a function to enough arguments.
That's pretty interesting wording, ain't it?
Yeah. Yeah.
It's definitely different from other languages. So yeah, so we got to give it, if we say double and we pass in the string hello, we get an error saying basically when it hits the plus operator here, the plus operator doesn't work with a list of characters, so we get an error. And then here, this is our first function we can create in the in a file. So all files, if you're going to create a function, they pretty much start out like this, and then we can define the function.
Yep. So there's a lot of similarities to Elixir. I can see that.
Or there's a lot of similarities in Elixir to Haskell.
Yeah, but actually, the reason I word it that way is because I want to say, hey, we have some Elixir projects at Agile Ventures.
Oh yeah.
Maybe Nick wants to help out.
I do want to learn Elixir at some point.
Yeah. All right.
So I gotta finish school first before I do anything like that, though.
Okay, I guess.
You guess. For the rest of the day, I'm going to be working on school stuff. So.
All right. I guess that's a good excuse.
Yeah, and then I'll be watching TV shows. So.
Yeah, no, I guess. I'm not so sure about that one though. Depends on the show, right?
Yeah. I think it's called Friends. Yeah.
No. Elixir is way better than Friends.
All right, so what are we doing here?
How are we doing on time, actually? I guess we did start 30 minutes after, I think, right?
Yeah. So, yeah, we did start 30 minutes after, so we've been going about 50 minutes. So maybe we could wrap it up.
It's up to you. We could wrap it up or go another 10 minutes. Or...
Let's see. So here, so yeah, so we got double. So here's where this, I got this in this file here. So let me see, how do I start up a console? Do you know how I get my console back?
You just go to that plus sign right there on the right. The fastest way, I think.
Oh, cool.
Oh, option T, I guess.
Okay. I put it down here. Oh, there we go.
It's a shame that C9 is going away.
It is?
They announced it, yeah.
Amazon's getting rid of it?
Yeah, it's like I forgot
cost them money.
I think so. So they're phasing it out at the end of June. They're getting rid of some functionality. I forgot what exactly, and then by the end of the year, they're gonna retire it completely.
Oh man.
Yeah, I don't know. It's a shame. I kind of like it because I don't know. It kind of works most of the time, but there is some trouble with it.
I don't know.
For the mobs, there are some issues sometimes, but yeah, I guess there's live share, which also works most of the time, but I guess it's more realistic environment. So that's how you load that file. Okay.
Yeah, so you would type :load and then wherever the file is at. So now it's loaded and I get this like main prompt. So now I can do like double 5, we get 10. Double 10, get 20. All right, it works. 10 plus 10 is 20. So I can say like let y, and I can bind that to 8, right? Now I can say double y, I get 16 back. So pretty basic stuff. That's how you load up a file. Let's load up a little bit more interesting one, and then right before we go. So we got this, let's see. Why did it load it up down there? So here's the same thing. Oh, it's missing something. We haven't seen this yet. So this is the same. It's the same function, but now we're telling it to say, hey, it's going to take in an integer and it's going to return an integer. So let's see how that works. So do load, it's going to be double with type.hs. Now if we say double 5, all right, it works. So now let's try double some string. And so here you see it couldn't match expected type integer with actual type list of characters. So this is a different error we got earlier when we tried to do, did I try to do it earlier?
I don't see it.
Yeah, I thought I did. Let's do it right now. So double string. Okay. Oh yeah, right there. Double hello, double string. So you see, so it says no instance for num list character arising from use of double, because we got an error when it hit the plus sign. So there's, but now if we say, now we add the type saying, hey, double, the function double, it's going to take in an integer, it's going to return an integer. So now it's erroring out right there before it even gets to the plus sign. So we get a little bit different error. And it says that in the first argument of double, namely string, it couldn't match the expected type. It was expecting an integer, but the actual type was a list of characters. So we get a little bit better error there.
Yeah, better error message. It's like almost like an assertion. Error message from like RSpec or yeah, XUnit.
So here's a recursion, doing some recursion in Haskell. So basically, this is our base case. And this, we're just calling the function factorial. We'll do just x times x minus 1.
So could you load that with like a string to see what happens?
Sure.
It's the error message, I guess. I mean, yeah, I mean it should fail, right? If you do factorial like 1 in quotes or something, or like 3 in quotes.
I'll do 3 in quotes. Like what? Huh?
Yeah, just because you haven't sort of declared the types,
right?
So I was just curious to see what the error message would be.
Okay. If I just try to run this with a string.
Yeah.
Okay. So we do factorial hello.
And just to make sure, like if you did a 3 in quotes.
And then we do factorial 3 x6.
Oh, sorry, 3. Yeah. So I kind of understood that to work, but like a 3 in quotes.
Oh, in quotes.
Mm-hmm.
I see. So yeah, the same error. They're both a list of characters. Single quote. Single quotes. Same thing. It's a list of characters.
So I wonder, like how we were talking about classes. I wonder if a num is a more general type of type, to where like an integer is more specific, or like a double also.
Yeah.
Because right there it says num, right? But earlier when you actually had the types declared, it said integer because you declared it as integer.
Oh, right. So yeah, so if we try to, if I load up the double.hs, which is declared as an integer, and we try to double 5.0, we get back 10.0.
Yeah, could you show double for a second? The font?
Oh, I don't have it declared.
Oh yeah, so that's.
Oh, there we go. Double with type. That's what I want to do. All right. So load Haskell double with type. All right. So now if we do double 5, we get back 10. If we do double 5.0, all right. So yeah, we get an error. No instance for fractional integer. arising from the literal 5.
That's cool. By the way, the group just got bigger.
Oh, hey, Joseph.
Hi.
Hey, Joseph.
I wonder.
Looks like no one has said hi to you, Federico. So I think Nick should say hi.
What? Did I not say hi, Joseph?
No, to me. He said to me.
No, you haven't
Why
said
would I
hi
say hi to
to
Federico?
Yeah,
Yeah.
yeah.
So the chat is like, I saw the chat because you're sharing the screen. I saw hi Nick,
Oh, I see.
then hi Joseph. Then I thought,
Oh,
so you're the-
yeah. The chat in the chat.
I think we were actually wrapping up, Joseph. But why did you show up so late?
yeah, I didn't see the notification.
Oh, okay.
I had muted my notification, but it's okay. See, you're doing Haskell, Haskell.
Yeah, we were talking about that, how it's really pronounced. I think we found out that it is Haskell.
Oh,
So yeah, so here's the support for most types. So here's the numbers right here. It's more general, like you said.
Mm-hmm.
And then integers is pretty specific down here. Here's fractional number, real floating numbers. So yeah.
All right.
What? Haskell. So yeah, so that's with types. I don't know. Did you?
I mean, I learned a lot more right now than talking about learning it with Amos King. So thanks for that intro.
Yeah, no worries.
Yeah, Joseph, do you know Haskell?
no.
Oh, okay. You could have learned a lot if you had your notifications turned on.
So yeah, so that's a little introduction to Haskell. We didn't get into any recursion today. I can, if you want, real quick, because I got all the files typed up. We even got this JavaScript file. It does the factorial. So let's see, node Haskell fact.js. This is doing factorial on 1000. Notice how it returns infinity. Okay, let's do factorial on 100. It returns some big number, 9.33 e to plus 157. All right, let's do a smaller number. Let's do factorial 10. In JavaScript, it returns 36.28800. And that's because in order to do this, in order to get big numbers added correctly in JavaScript, we need to do the big num. We got to do a lot more code than just this, these few lines, right? We got to load up the big num and do all that. In Haskell, we got the same code right here. So if we load this up and let's see fact.hs. All right, so let's do factorial 10. All right, we get back the same number we did in JavaScript.
Wait, that's the code that's running. Like line 3, that's a function.
So this is a function, and this is a function.
What do you think, Joseph?
Wow. So now factorial. So let's do factorial. Let's see, we did 10. Let's do 100. And then we get back, instead of 9.33 e to plus 157, we get back the entire number for factorial 100. That's factorial 100. If we do factorial 1000, we get back factorial 1000. We don't, and this is mainly due to Haskell's type inference and lazy processing. It's able to calculate this because of mostly due to lazy processing. That's Haskell, or that's factorial 10,000 right there. And I can't scroll up on this terminal, but yeah. Anyway, so yeah, so that's first introduction to recursion. So basically, it's going through factorial. If we pass in factorial 0, it's just going to return 1. It's going to match that and return 1. Factorial 1 returns 1. Factorial 0 returns 1. Basically, what happens is that factorial 0, it hits this. It's got a function for it, so it just returns 1. When you pass in factorial 1, it doesn't match that 0, so it matches this x. So it says 1 times factorial 1 minus 1. Well, 1 minus 1 is factorial 0. So then it comes here. So it runs through this again, and it sees, oh, factorial 0, it returns a 1. So 1 times 1 is 1, so we get back 1. So factorial 2, it'll basically do all that. And we get back 2, because it goes 2 times factorial 2 minus 1, which is 1, which you already know is 1. So 2 times 1 is 2, times 1 is 2. Factorial 3, we get back 6.
I think Joseph had a question.
Yeah,
Or
go ahead.
he was impressed by something.
Yeah, like line 3, so that, like, where is even the parameter?
It's a 0. So think of the equal sign more like a fat arrow in JavaScript.
Oh, okay.
And then that'll make more sense.
So like the 0 is the, so you can name it whatever you want, like on line 3. You can say like, oh, wait, Haskell is just for math, right? You can't do program. Can you?
Haskell is not just for math. It's a full programming language. You can do everything in Haskell. You can do anything in Haskell. You can do anything. Anything you can do in a different programming language, you can do in Haskell.
So it's just, so that 0 there, Joseph, it's, yeah, so this is what you, Joseph, and I, Mike and I were talking about in a session, I think this week sometime, where it's called like almost functional matching. In Elixir, you, instead of doing if and else so much, you actually match through the parameters. And you have like several different functions that have the same name, like right there, and they're grouped within the module. So right there, that function is called factorial, and it'll first, depending on what's first. I think if you reverse the order, I don't know if you want to try it, Nick, but if you reverse the order of those and then pass in 0, actually, what would it be actually? So it matters the order. If it first, yeah, and pattern matches, yeah.
Infinite loop.
Right. Okay. Yeah, that makes
'Cause
sense.
it never reaches this. So factorial 0, it matches x
Every time. Yeah.
every time. So it never reaches 0. So we get we get stuck in an infinite loop. So
Mhm.
this, you can kind of think of this as our base case.
Right.
And so it's a base case and still a function definition.
Right. Exactly.
Interesting.
I broke,
And
I broke C9.
what about the where?
I
Where
don't know.
what? Like, it's just, I'm wondering, like, where? Like,
Maybe it's like a
What?
do, like you see in Ruby.
sorry?
Maybe it's like a do, like you see in Ruby and Elixir.
Oh, so you're not importing module name where you can find it somewhere.
No, that's you're defining the module. This is the definition of the module. This file.
Oh, oh, I thought it was like C++ where you need to import, I don't know, standard in, standard out.
No, I'm pretty sure it's called main. Am I right, Nick?
What's that?
Am I right that we're defining main right here? This is the module main. We're not like importing main, right?
Right. You're defining the module main. And every Haskell file needs a module main. So when we load up this file, it's basically saying, okay, we're running module main. That's why it says main right there.
Could you just change that to like main with like main the state or something? I don't know.
Sure, but I think I broke C9.
Oh no. Oh no. Yeah. So I guess you have to close that. Yeah.
All right, let me open up a new terminal. All right, what should I name this? Hello?
Anything else? Yeah.
All right, let's load up the compiler. Then load Haskell /HS. Okay, modules loaded. Hello. And we get hello there. Oh, let's see if it works. Looks like it's going to work. Factorial 3. And 6.
Okay. Yeah.
Yeah. So I don't know. The book said that. Yeah, I don't know.
I mean, maybe it's like if you have a program where you have different modules, you have to at least have a main module, sort of almost like a project or like a more
Right
like
here it says the main module is special. It is a top level module.
okay.
That's all it says.
Yeah. It's kind of like a mix between like C and like Elixir, or maybe even like Go. It's kind of like Go, where you have to have a main module, but in the other module, that's how you name them.
Yeah.
And we're not importing there at all. It's the name of the module. Got it. Does that make sense? Just
Yeah.
okay.
So here we can do that same factorial function. We do let fact x, and then we could do like we'll say okay. So this we're defining fact. Well, I'll call it factorial. Here we're defining a function factorial. The let keyword. So we're saying it takes in one parameter x, and then we'll say if x is equal to 0, then we want to return 1. Else we want to return factorial x minus 1 times x. So if we do factorial 0, we get back 1. Factorial 1, 2, 3, 4, 5. So this is the same code we have, except now we're using the if function to say, well, if x, it might be a little bit easier to understand than where did it go? Than this, right?
Yeah.
So let factorial x, if x is equal to 0, then we're returning 1. So that's basically what, right there, that's basically what this is doing. If the x is equal to 0, then we're returning 1. Else we're going to do some recursion. Call factorial again, and we'll pass in x minus 1, and we'll multiply that to x. And there's factorial, whatever number I typed in.
Yeah, be careful. You might lock up your
10,000. So I can pretty much put in any number and it will not lock up my computer.
Okay, yeah. Just don't reverse the.
Because I won't get any stack overflows because it's not creating a stack here due to the lazy processing.
Oh yeah. Okay. That's neat.
So, yeah, I will not get any stack overflows, and it will pretty much evaluate any number I pass in.
Oh, that's cool. Just
Factorial
don't reverse the if and the
99999999999. Might take a while, but it'll work.
We might be here a while.
What did I do last time? I think I did 100,000. Oh, exception. Oh, I did get a stack overflow. Okay. So this one caused a stack overflow, probably because of the order that the recursion is in. If I put that at the end, I might not get, I wonder if I'll get a factorial. Wonder if I'll get a stack overflow.
Well, now you gotta try it real quick.
I do. I don't know if it got that stack overflow because it was about the same time I hit Control D, so I don't know which one happened first. Let's see. We do. I'll wait 10 seconds.
Okay.
Get a stack overflow. Yeah. So
Go for the infinite loop.
So yeah, so I guess I do get a stack overflow. There are some ways that I saw. We had come to a pretty cool experiment in one of the sessions where, like Ruby and JavaScript, we wrote the same code in like JavaScript, or it was Ruby, I don't remember. And we wrote the same code in Haskell, and at a certain number, we got a stack overflow in like the other programming language, whereas Haskell just didn't get any stack overflows no matter how high we went. And that might have been because how we were doing the recursion in Haskell. It was a very efficient way to do it, I guess. Because of the lazy. Oh, here we're doing factorial. Actually, what I should try to do, we do factorial x minus 1, but here, let's put the x over here. Yeah, so get a stack overflow. All right. Anyway, that's enough for today.
Okay.
But
Yeah, I'm good. I'm good.
yeah, you're good. I'm good.
Yeah, me too.
I'm glad everyone's good.
Cool.
Good. Yeah. Anyway, all right. So maybe I'll see you next week.
Yeah, maybe. I'll probably be
Sleeping.
back to my regular or my 2019 sleeping schedule.
Okay.
Well,
what's going on, Federico? You just working late or?
it's just I got like I think partially I blame the daily code kickoff.
Okay.
Like I wasn't like be able to get my normal sleeping schedule, and that threw me off. And then so the only time that I was really finding to be able to sleep was during the Agile Ventures hours. And then yeah. But anyway, no one cares about that. So yeah, thanks, Nick. It was yeah, it makes me want to try to make it to the next one because I kind of like Haskell.
Yeah, it's pretty cool. It's pretty interesting to learn, get another perspective on how to do things.
Yeah.
Yeah, for sure, for sure. Well, all right. Thanks, Nick.
All right, thank you.
Bye.
All right, see you guys.
Bye.